Okay, so today I'm going to go over two more questions from the Calculus and Vectors Nelson textbook. This is part of the 1.5 evaluating limits section where you have to use the change of variable method. And oftentimes this can be a bit tricky because people often don't know how to set up the let statements or what to really look for. So I will try my best to explain this in a way that will make complete sense. This is also page 46, questions 8, parts D and F. Okay, so question number D is saying the limit as x approaches 1 of x to the 1 over 6 minus 1 all over x to the 1/3 minus 1. Right now, one way we can solve this question is by using the change of variable method, where we will choose any letter and set it equal to x to the 1/6 or x to the 1/3. But the question is, what are we going to choose? Right now, the issue we have with this is if we plug in 1, we're going to get 1 minus 1 at the bottom, which is equal to 0. And we cannot divide by 0. So what we can do is we can set up some let statements. We can go ahead and say let u equal x to the 1/6. And the reason I'm going to choose x to the 1/6 is so I can easily modify this into x to the 1/3 later on. Now for x to the 1/3, all I have to do is just square the u. So we can say u squared is equal to x to the 1/6 all squared. And remembering your exponent laws, we will just multiply with the fraction, the exponent. This gives us x to the 2/6, which can then be simplified to x to the 1 over 3. Now this is perfect for us. Right now we have the limit as x approaches 1. However, we want it in terms of u because we changed everything to u. All we have to do is plug in x equals 1 into u equals x to the 1 over 6. This gives us 1 to the 1 over 6, which is just equal to 1. Therefore, this will be u approaches 1. We can now go ahead and rewrite this as the limit as u approaches 1 of u minus 1 over u squared minus 1. Now I notice at the bottom I can factor this out because this is a difference of squares. I can now rewrite this as the limit as u approaches 1 of u minus 1 all over u plus 1 multiplied by u minus 1. I now see that the u minus 1 simply just cancel out, leaving me with the limit as u approaches 1 of 1 over u plus 1. I can now get rid of my limit notation and just go ahead and plug in 1. This leaves me with 1 over 1 plus 1, which is 1 over 2. You can also write 0.5 as your answer. The next question is saying the limit as x approaches 0 of x plus 8 to the 1 over 3 minus 2 all over x. Once again, we have to make some let statements for the change of variable method. We can say let u equal x plus 8 to the 1/3. Keep in mind this is the same thing as saying the cube root of x plus 8. Now the question is, but what is x going to be? Well, we can easily find what x is by cubing both sides to get rid of the 1/3. Or in other words, the cubed. This leaves us with u cubed is equal to x plus 8, and isolating for x, we get x is equal to u cubed minus 8. Now we want everything in terms of u, so all we have to do is plug in x equals 0 into u equals x plus 8 to the 1/3. Plugging in 0, we get u is equal to 2. Therefore, u is going to approach 2. We can now rewrite this as the limit as u approaches 2 of u minus 2 all over u cubed minus 8. At the bottom I see we have a difference of cubes, and I'll show you an acronym that makes it very easy to remember how to do this. And keep in mind, we just substituted everything we said earlier. The acronym is called SOAP. It stands for same, opposite, and always positive. We can now rewrite this as the limit as u approaches 2 of u minus 2 all over u cubed minus 2 cubed. This is where the SOAP part comes in. We can rewrite this as the limit of u approaches 2 of u minus 2 over u minus 2 multiplied by u squared plus 2u plus 4. And just to explain how I got those two brackets, the first bracket will be the first term minus the second term, and then the second bracket, it will be the first term squared plus the second term multiplied by the first term plus the second term squared. Here's a quick rundown of the difference of cubes formula. In this case, we had case number 2 because we had u cubed minus 2 cubed. Moving on, I see that the u minus 2 simply just cancel out, leaving me with the limit as u approaches 2 of 1 over u squared plus 2u plus 4. I can now go ahead and get rid of my limit notation and simply just plug in u equals 2 everywhere I see a u. This leaves me with 1 over 12 as my final answer.